Now here is a question on linear transformation where we have the transformation T is such that R4 is mapped onto R4 and is represented by this matrix. We need to find the dimension of the range space of T. Now to be able to do that, I'm just going to reduce this to the reduced row echelon form. And if we do that, okay, you can just do it manually. All right, you should be able to get something like 1 0 0 0 0 1 0 negative 1 0 0 1 1 and then 0 0 0 0. Counting the pivot columns 1 2 3, 3 pivots, so the dimension of the range space of T, okay, I'm going to call it dimension of the range space of T is going to be equal to 3. Now we need to find a basis for the null space. To be able to do that, what I'm going to do here is I'm just going to set up an equation. You're just going to multiply this by x1, x2, x3, x4 and say that this is going to be equal to the 0 vector. Okay, so here we are. Because the system is consistent with 2 zeros here, so I can say that this is basically of the form hx is equal to the 0 vector. So now what we have is x1 clearly is 0. So we've got x1 as 0. So maybe I can find a basis for the null space of T. So the null space of T is going to be equal to, I've got a 0 here, x1. And then x2 here minus, so this is 0. x2 minus x4. So x2 minus x4 is equal to 0. So basically x2 is equal to x4. And then x3 plus x4 is equal to 0. So we've got x3 plus x4 is equal to 0. That means x3 is going to be equal to negative x4. So because this is the x4, this is my free variable. So I can let x4 is equal to t. So in that case, then if x4 is equal to t, I'm going to get something like this, 0, and then because this is t, so x2 is equal to t, x3 is equal to minus t, and then x4 is equal to t. So we are looking at a vector something like this, 0, 1, negative 1, 1 times the parameter t. So a basis for the null space is then 0, 1, negative 1, 1. So that's my basis for the null space of T. It is given that x satisfies the equation hx is equal to all of that. So basically what we're saying is that hx here is equal to some vector b, and also that h times this vector here is equal to the same as this. So basically this is my particular solution. We're talking about the, because we need to use the fact that h times this is equal to all of that, which is the same as here. So basically they are actually commanding us to use the general solution of a linear system. So the general solution is made up of the particular solution. This is my particular solution, plus the homogeneous solution. The homogeneous is basically this one here. And so what I'm going to do is I'm going to call this this x here. All right. So I'm going to say x is equal to, so x is equal to the particular solution, which is basically 1 minus 3, 1 minus 2. So 1 minus 3, 1 minus 2, plus the general solution. And the general solution will be the this vector here, the vector vt. So I'm just going to call this the vector v. And vector v turns out to be the null space, which is 0, 1, minus 1, 1. So 0, 1, minus 1, 1. All of that being multiplied by t here. And because now this here, it solves the linear system of the homogeneous Therefore, I'm going to say that if I'm looking for a least value here, because they say find the least possible value of x, which is of this form. So, and that x, that modulus of x, is going to be equal to the square root of x1 to the square plus x2 to the square and so on until x4 to the square. So basically what I'm looking at then is that x, my vector x, is going to be equal to all of that here, 0 to the square plus 1 to the square plus negative 1 to the square plus 1 to the square. So basically I'm looking at the square root of 3. The reason I've taken this, because that's going to give me the least value. It solves the homogeneous system. If I take this one here, the particular solution, then x is perhaps going to be greater than the square root of 3. So that's my least value here. So this vector v here is a linear combination of all of the system of equation. So here we are. I hope this has been of some help to you. However, you may be wondering about the reduced row echelon form. Of course, for this one here, you can use a calculator, but for this A-level exams, you're not allowed to use any calculator that will give you the RREF form of this matrix. So basically what you're going to do is you're going to use the method that's been explained in your book or from your lessons, from your teacher. So you should be able to know how to reduce this to the reduced row echelon form by eliminating elements in the various rows until you come to this one here, which is basically where you can't reduce it anymore. All right, take care.